Good morning, students. And last class we discussed about that gas forward, okay, gas forward and gas backward. So last class we discussed gas forward and backward, and the Newtons also in the same thing. The Newtons also, okay. Uh, Now today we are going to discuss about that differentiation. Today we are going to discuss about the differentiation, okay. Numerical differentiation. See, Lisa, here the concept is the different. So we have to see that numerical differentiation. So the differentiation, the numerical differentiation. And it's very important. Okay. So before that, we have to learn what is the differentiation. Okay. So what is the differentiation? Let's see here. Suppose we are at 3 o'clock at Koti, like BRAOU. So we are at BRAOU. Okay. After 1 hour, we are at Koti. Or at 4 o'clock, we are at MGBS bus station. Okay. See, let's see what will happen is there here. At 3 o'clock, we are at Koti. We are at BRAOU. So after 4 o'clock, we are at MGBS. See, what is happening here? Our place is changed according to the time. So that is called in the mathematics, that is called the speed. So speed equal to distance by time. Understood? Now you got it, right? What is the speed and what is that? Okay. Now understood? Yeah. And let's see some more. Next, see. Uh, yeah, that's we call in the physics, that is called that speed equal to distance by time. Now come to in that velocity. So what is the velocity? The displacement by time. So the rate of change of displacement is called velocity. And finally that we are getting to the acceleration. So that equal to dv by dt. Okay, that's we can write. This we can write dy by dt, and v equal to what is that? ds by dt. Okay, so that we can write what is that? D square s by dt square. So this is the acceleration. So one thing, what is that? Differentiation means the rate of change of one variable. So with respect to another variable. So that is called what is that? Differentiation. Okay. So you should remember. Now we are going to differentiation means what is that? Numerical differentiation. So how we can the rate of change of numerical differentiation. Okay. So I will share the PDF. And previous we find out that I will tell the table now. See, this is the x values, and this is the y values, and this is delta y naught, y delta y, and delta square y, and delta cube y. Okay, so x and y. So let's take this is x naught, x1, and x2, and x3. So corresponding that y values y0, y1 and y2 and y3. Now let's see these two differences. That is we call delta y0 and this two difference that is called delta y1 and this two differentiation that is called delta y and this two differentiation that is called delta square y1 and this two differentiation that is called delta square y2. Okay, next, this two differentiation is called what is it? Delta Q y1. Okay, na? So this is the table. So in this table, so how we can find the first derivative and second derivative? Okay, so first derivative that is called dy by dx. Okay, and let's see the first derivative. So what will happen? See there. Just see what is the formula of the first derivative. Yeah. See what is the first derivative is become 1 by h into, okay, so 1 by h into delta y naught minus delta square y naught by 2 plus delta cube y naught by 3 plus so on. Okay, so this is the first derivative. And in that the same point, and what is the second derivative? The d square y by dx square. Let's see what is the d square y by dx. So for d square y by dx square, so that we can write 1 by h square. So 1 by h square delta square y naught minus delta cube y naught by 3 plus 11 by 12 and delta 4 of y naught plus minus so on. So we should remember dy by dx and d square y by dx square. So this is the first derivative. So first derivative of the finite differentiations. Now understood? So this is the dy by dx 1 by h. So here what is the h? So what is the h means? Let's see, this is the difference between these two is called h. And same, this is equal interval that is called h. And this is also called that h. Okay, so this is that uh, uh, the difference between the conjugate is x values. So it should be same. So that is called that h. Okay, understood? Next. So this is the first differentiation formula and this is the second differentiation formula. Okay. Now let's see. I will share the PDF more. Please be online. Share the PDF. Yeah. So this is the just now we discussed the problem. No, easy. They're asking what is that? They given this some table and they're asking to find that first derivative and second derivative at the point 0.1. Okay. So we know the formula. Just now we discussed about that formula. So just we first draw the differentiation table. So it is very important to draw the differentiation table. Okay. So to draw the differentiation table is a very important. So first they are given the values. X values 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.5. And the corresponding Y values they are given. So first, how we can find the delta effects means the difference between these two. That means 1.56 minus 1.40. Okay. So 1.46 minus 1. See, so this is that differentiations, and the same thing. This two differentiation that is 0.20, and this two differentiation is 0.24, and this two differentiation is 0.28. And similarly, this two differentiation, you know how we can find the differentiation tables. And this all are equal, and this is 2 is 0, and this 2 is 0, and this 2 that is 0. Okay. Now this is the uh, differentiation table. Okay. Now step we need to find out delta y naught and what is about the delta square y naught. So this is the delta y naught value, and this is delta y naught, and this is the delta square y naught, and this is the delta cube y naught, and this is the delta power of 4 y naught value. Okay. Now let's see here. So all the values we have now. So we have to substitute in this here. That formula just now we discussed, no? That formula we need to substitute. We have to tell what is the formula means. See, the formula is we need to substitute that formula. What is that formula? Delta y naught equal to first derivative, that is 1 by h into. So 1 by h into delta y naught minus delta square y naught by 2 plus delta cube y naught by 3. Okay. So delta y naught value is 0.16, and delta square is 0.04, and delta cube that is 0. And similarly in the second derivation also we need to find out. So that we are getting to the values of the uh, f dash of x and f double dash of x. Okay. So this is the things we can do that. Okay. And So now let's see the next problem. See, they're asking if they're given sine 45, sine 50, sine 55, and sine 60. So they're asking to find cos 45. So cos 45, so the cos 45 is nothing to what is that? How we can find the cos 45? Cos theta is the differentiation of the sine theta. So in the same way, so if you are finding the derivation of sine 45 and we are getting to that cos 40. So first we have to draw the table. Okay. So this is the differentiation tables. So this is the differentiation tables. 45, 50, 55, and their corresponding and their differentiation. Their differentiation. In the same way their differentiation. The same way their differentiation. And in the same way their differentiation. Okay. Now the cos 45. No? So this is delta y naught. Okay, this is delta square y naught. Okay, and this is delta cube y naught. Okay, now we need to substitute all the values there. So then we are getting to the cos 45 value. That 1 by h. So h means the difference. So the difference is 5 degrees. So 5 degrees equal to this thing. Okay. So when you are accurate to that 4 decimal places, that is 0.707. Okay, and using from there also we can get that f double dash 0.1 also. Now that is the forward differentiation formula. Now using that backward differentiation formula. So there will be there. Yeah. Let's see here. Now see that forward backward difference table. The backward difference table. Differentiation. So backward differentiation. Okay. And this in there dy by dx equal to 1 by h into. So here all the plus values will become nabla plus nabla yn here. We are taking that nabla yn and nabla square yn plus nabla cube yn plus so on. So here observe one thing. So this is forward difference table and this is the backward difference table. So here all the place will become. Here the symbol is delta and here the symbol is nabla. Okay. And the symbol is delta and here the symbol is that nabla. Now got it your, that is the things we can use in that. Okay, the formula now come to second differentiation. Second differentiation. So when you are using the second differentiation, So here also the second differentiation here, all are negative, no? So now you see the second differentiation, d square y by dx square. So what is the second differentiation means? So 1 by h square. So 1 by h square, nabla square plus nabla cube. Remember one thing. Plus 11 by 12. Here all the place will become 11 by 12 nabla power of 4 plus 5 by 6 nabla power of 5. So, so this is first derivation and this is a second derivation. Understood? So this is backward. So this is a backward differentiation. Okay. Now, so this is forward. So forward differentiation. And this is the backward differentiation. So these are the two formulas. Okay. Now we are going to, I will share the PDF and we'll see the what are the problems on it. Okay. Now I will share the PDF. We'll do those problems on backward and forward. Ah. See, the table below is given the values for tan x and they're asking to find secant square 30. So generally we know that the differentiation of tan x is what is that? Secant square x. So the difference of tan x is secant square x, no? So we need to find the derivation. They're asking to what is that secant square 30. So we know that tan 30, they already they given. So we need to find secant square 30. That means, so we need to find the derivation, the backward derivation. So we use the backward derivation formula. So we are getting that. So uh, we know that how we can find the differentiation table. Okay. So now let's see the backward differentiation table. Let's see the backward differentiation table. Okay. So here the h value, the difference between these two, and that h value, the difference between these two. Here also h value, the difference between these two. So equal interval will be there. So delta of fx that we are taking these two differentiations, and this is the two differentiation, and these two differentiations, and these two differentiations. So in the same way, here also this two differentiation, and 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 finally this one. So here we are using the backward no. So this is called nabla y naught, and see I will. So this is nabla y naught, and this is nabla square y naught, and this is nabla cube y naught. This is nabla 4 of y naught. Okay. So we can substitute that formula. So in that we have that formula, no? What is that? Nabla y naught 1 by h into, sorry. So 1 by h into nabla y naught plus nabla square y naught by 2 and 1 by 3 into nabla cube y naught plus 1 by 4 into nabla 4 of y naught. Okay, so these are the uh, backward. So here we are getting one doubt. So when we are using the forward and when we are using the backward, so that is important, no? Okay. See, when we are using the forward and when we are using the backward, let's see. This is x values and this is the y values. Uh, 1 and this is 3 and this is 5 and this is 7 and this is 9. Okay. If they are asking to find the derivation h f dash of 1. So f dash of 1. So this is we are using to forward. If this is we can use what is that forward. If they are asking to find f dash of 9. So this is come down no. So that we have to use what is that backward. So understood? So that is forward and backward. In the same way, if they are asking to f dash of 3. So that is also using the forward. And if asking to that f dash of 7, that we are using to the backward. Okay. And the middle thing that we are using that central differentiation table. Now understood in the examination, they will not mention which understood. So this is for these two, we need to use the backward. X and Y. 1, 3, 5, 7, 9. For these two, we have to use that forward. And for these two, we should use what is that backward. Okay, forward and back. And this we can use the central differentiation formula. So that is different. Now you understood? Okay. And now we'll go to the problem. So this is a central difference formula. Okay. See this one example problem. For example problem 4. So we need to find dy by dx, the df by dt, and d square f by dx square. So d square f by d at 0.3. Okay. See here the important concept I will tell. If they're asking to 0.1 and 0.2, okay, then we are using that which things we have to use? Forward. Okay, and this is also we can use that forward. And now if they're asking 0.6 and 0.5, so this we have to use what is it? Backward. So above is the forward and down is what is it? Backward. So understood? But if they're asking to that middle terms, these two things, so we have to use what is it? Forward differentiation, the central differentiation table. So this is. So how we can calculate the two values means, okay. So first we are taking the delta f y naught and mu into delta f naught. How we can calculate it means, so 1 by 2 into these two values. So you know how to draw the table that already we know that thing, no? Okay. So here officially that we are getting the capital T. That capital T is T minus 0.3 by the what is the difference will be there. So T equal where we can find out that 0.3, no, that small t value equal to 0.3. So we are getting this. So del here we need to find out. Here we need to find out. Okay. So the delta f y naught is okay. So this by this two. Oh, sorry. 1 by 2 into this 2. Okay. And next to delta square the delta cube 1 by 2 into this 2. And the final thing, this is, so now you understood 1 by 2 into delta. Okay. So this is all the values. So all the values we should substitute in that formula. So then we are getting that velocity. So dv by dt. So that is nothing to what is it? The first differentiation. So they're asking to find the acceleration also, no? The second differentiation, and this is f double dash into 0.3. Okay. See one example problem. From the following table, so we need to estimate that f dash of 0 and f dash of 1.5. Okay. See, first we construct one polynomial function. Then we can find out that from the polynomial function, so we can find out that f dash of 0 and f dash of 1.5. So that values we can find out from there. Okay. See, this is values, and 0 minus 1 is -1, and 1 minus 0 is 1, and 10 minus 1 is -9. Next, this is 2, and 9 minus 1 is 8. Next, 8 minus 2 is a 6. Okay. So, let me assume that polynomial functions, how we can find out. Delta f naught is -1, and delta square f x is 2, and delta cube f of x equal to 6. So in that equation 19 means here we can substitute that. So this is p equal to x. Huh? So from here we can substitute. So we are getting that polynomial, the first derivation polynomial. So this is so this is yeah. So from here, so then is f of x is that x cube minus 2x square plus 1. From here, we can find out that any value, they are asking to that any value in the interval 0, comma 2. So this is the function, no? F of x equal to x cube minus 2x square plus 1, no? From here, we can find out that any value. They are asking only for f dash of 0, f dash of 1.5. They are asking to f dash of 2.2 also. So just we should substitute, what is that? In place of x, we should substitute that 2.2. So that f dash of 2.2. Okay, this is f dash of 1.5 value, and this is BRB. Okay, so this is so same thing backward. This is central differentiation formulas. So in between values, so remember one thing. So this is the important using Stirling formula. Using Stirling formula for finite differentiation, and find f dash of 1.4 from the given following table. Okay, so this is the 1.0, 1.2, 1.4, 1.6, 1.8. That is -2, -1, 0. So this is the nearest to, they're asking 1.4, no, that we are taking to the 0. And this 1, and this is 2. So this is equal interval. So then equal interval. Sigma, that's compulsory in the examination. This is important. Stirling. Stirling form. Okay. So this is. So what are the values initially? Just now we discussed, no? 1/2 into the summation of these two. Next to 1 by 6 into, so that is 1 by 6 into the summation of these two. Okay, so this is we can do as one more thing. So it's very important theorem, problem. Here also Lagrange interpolation formula. It's very easy. That Lagrange interpolation formula. Okay, see, I'll share the whiteboard. Lagrange interpolation formula. So this is very important. So what is a Lagrange interpolation formula? Means f of x equal to x minus x1 into x minus x2, so x minus xn by x naught minus x1, x naught minus x2, so on x naught minus xn into f of x naught plus next x minus x naught, x minus x2, so on x minus xn by x1 minus x naught and x1 minus x2, so on x1 minus xn into f of x1 plus so on. So this is the formula of the Lagrange interpolation formula. Okay. So here, what is the x value means? If they're asking to find f of 0.3, so this value is going to that x value. Okay. So when we are using the Lagrange interpolation formula means it is unequal intervals. Okay. So like suppose see that x values and y values. See one, let's take 4 and 6, 11. See what are the interval is there. Here the difference is 3 and here difference is 2 and here this is difference is 5. So that unequal intervals. So we need get that value Lagrange formula. So generally otherwise we can use that Newton's forward and Newton's backward differentiation formula. But this time only we are getting this thing. Okay. This is okay. That is the formula and we'll go to the one formula. They are given x naught 1, x2 3 and they are asking to find f dash of 1 and f dash of 2. Now here observe that the interval is what is that? This is 2 and this is 1 and this is 2. So that is unequal intervals. So in the examination, they will not mention using the Newton's forward, Newton's backward or Lagrange. So first we should observe the question and then only we can get that uh, it's backward or forward or Lagrange interpolation. So one thing you should remember one thing. So when it is Lagrange means unequal intervals. So we can find out that the Lagrange interpolation formula. Okay, understood. So this is that, and this is the formula. Just now we discussed now. So this is the formula. X minus x1. So this is x1. X minus x2. X minus x3 by x naught minus x1. X naught minus x2. X naught. And f of x naught. F of x naught value is what is it? 3. Okay. So this type of questions in the examination they will ask. So from here we can find out that any values. Put f dash of one value and f dash of two value. So any values we can find out. And do this is as a homework. Okay. So finally, I should tell one thing. So this is x values and y values. 2, 4, 6, 12, 10, and some y naught, y1, y2, y3, y4. Okay. So when we use the forward means, so when we are using that forward means, for these two values, we can use that forward. Remember that. Okay. Suppose they're asking to find f dash of 2 and f dash of 4. So we can get the forward. 8 comma 10. So this we can use that backward. That means if they're asking f dash of 8 and f dash of 10. Okay. And for these things, we can use that drilling. Drilling difference table. For this, we can use that drilling difference table. This is when that equal interval. When they have that equal interval, we can do this thing. Okay. Suppose unequal interval will be. So unequal interval like 1, 3, 6, like 11 and 13. So this is x values and this is a y values. The corresponding is y naught, y1, y2, y3, and y4. So unequal intervals. This is 2, and this is 3, and this is 5. This is 2. So y naught, y1, y2, y. So this all this case. So we can use that. What is that? Lagrange's interpolation form. So this is the numerical differentiation. So if you have the textbook and you can solve that differentiation, numerical differentiation, forward differentiation formula and backward differentiation formula. Newton differentiation. So, so in that Newton differentiation, just to be learn out that Newton forward and backward and Stirling and Lagrange. So these are the topics will be there. So it's very easy topic. Okay. So it's very easy topic. You need to solve. It's very easy. So from next class, we'll discuss that one more topic.